Enkai, The Gathering World by Mark Reddick. Author's note: this book is not fiction. It is a map of something already unfolding. The technologies described here, personal data lockers, decentralized compute networks, sovereign digital identity, are not speculative. They exist, they are deployed, they are operational. What does not yet exist is the widespread understanding of how these technologies connect, how they form an infrastructure capable of returning control to individuals, how they enable a world where data is owned, not harvested, where compute power is distributed, not centralized, where identity is sovereign, not leased from platforms that can revoke it at will. I have spent years studying the intersection of blockchain, edge computing, and data sovereignty. I have watched centralized systems extract value from billions of people while offering nothing in return but convenience wrapped in surveillance. I have seen governments and corporations compete to own the infrastructure of human existence, our communications, our transactions, our movements, our thoughts, and I have seen the alternative, not in theory, but in practice. Enkai is not a product I invented. It is a system I architected by recognizing how existing technologies, built independently but with shared purpose, solve problems others believed unsolvable. The personal data locker from Jasmy, the distributed GPU network from Junction, the identity protocols, the compliance frameworks, the economic incentive structures. They all existed, but they existed in isolation. I saw the mycelium, the invisible network beneath the surface, the way these systems connect to form something greater than their parts, an infrastructure for human coordination that does not require trust in centralized authorities, a civilization operating system that runs on verification, not faith. This book is my attempt to show you what I see, to explain not just what is possible, but what is inevitable, to invite you into a world that is already gathering, even if most cannot yet see it. The question is not whether this future will arrive. The question is whether you will be early enough to shape it. Mark Reddick, February 2025. Prologue, The First Signal. The signal was weak at first, a tremor in the foundation of the digital world. Most people did not notice. They were too busy scrolling, posting, purchasing, streaming. They lived inside the platforms, unaware that the platforms were not neutral spaces, but privately owned infrastructure designed to extract value from every interaction. But some noticed. Developers, cryptographers, engineers who understood that the internet had been quietly colonized, that what was once a decentralized network of equals had become a series of walled gardens controlled by a handful of corporations, that Google, Meta, Amazon, and their counterparts were not just companies. They were digital landlords who owned the roads, the buildings, and the surveillance cameras. And a few of those engineers began building something different. Not as a political act, not as rebellion, simply as engineering. They asked a basic question: what would infrastructure look like if it were designed for people instead of platforms? What if data could be owned instead of rented? What if compute power could be distributed instead of centralized? What if identity could be sovereign instead of leased? They built protocols, they wrote code, they deployed networks, and slowly, quietly, an alternative infrastructure began to take shape. This is not a story about cryptocurrency. It is not a story about blockchain hype or get-rich-quick schemes. It is a story about infrastructure, about the invisible systems that determine what is possible in the digital world, about the fight for control over the operating system of civilization. The signal is no longer weak, it is growing stronger, the infrastructure is operational, the alternative is here. This is the story of Enkai, The Gathering World. Chapter 1, The Human Firewall. The year was 2023, and Sarah Chen was being tracked by 47 different companies. She did not know this. She had not given explicit permission to most of them. She had simply lived her life online, browsing, shopping, searching, scrolling, and in doing so, she had generated a data exhaust that was vacuumed up, analyzed, packaged, and sold to advertisers, data brokers, insurance companies, and anyone else willing to pay. Her phone knew where she went, when she went there, and how long she stayed. Her smart speaker recorded fragments of her conversations. Her fitness tracker monitored her heart rate, sleep patterns, and exercise routines. Her email provider scanned her messages. Her social media platforms built a psychological profile based on what she liked, shared, and lingered on. Her streaming services tracked her viewing habits. Her credit card company knew every purchase. All of this data was owned by someone else. Not her. She was not the customer. She was the product. This was not unique to Sarah. This was the default state of existence in the digital world. Every person with a smartphone, a laptop, or an internet connection was generating hundreds of data points per day. Every click, every search, every interaction was recorded. The data was aggregated, cross-referenced, and analyzed by machine learning algorithms designed to predict behavior, manipulate attention, and maximize engagement. The business model of the internet was surveillance, and most people had no idea how deep it went. Sarah worked as a marketing manager for a mid-sized e-commerce company. She spent her days optimizing ad campaigns, analyzing customer data, and running A/B tests to increase conversion rates. She understood intellectually that data was valuable. She used it every day, but she did not think deeply about what it meant that her own data, her location, her health, her communications, her purchases, was being used the same way, until she got the email. It was from her health insurance company. The subject line read, "Important update to your policy." She opened it, expecting a standard rate increase. Instead, she found a letter informing her that her premiums were being adjusted based on lifestyle risk factors identified through third-party data analysis. She read it 3 times. Then she called the insurance company. The representative was polite but unhelpful. "We use a variety of data sources to assess risk," he explained. "This allows us to offer more accurate pricing." "What data sources?" Sarah asked. "I don't have access to that specific information, but it's all outlined in the terms and conditions." She hung up and spent the next 2 hours searching for answers. She discovered that data brokers were selling aggregated health and lifestyle data to insurance companies, that her fitness tracker data, her grocery purchases, her social media activity, and even her search history could be used to assess her risk profile, that she had unknowingly consented to this when she clicked "I agree" on a dozen different privacy policies she had never read. She felt violated. Not because any single piece of data was particularly sensitive, but because the totality of it, the aggregate picture of her life, had been used to make decisions about her without her knowledge or consent. And she realized something fundamental. She did not own her own data. She had no control over who had access to it, how it was used, or what decisions were made based on it. Her digital identity was fragmented across dozens of platforms, each of which claimed ownership over a different piece of her life. This was the problem Enkai was designed to solve. Not through regulation, not through corporate goodwill, not through privacy policies that no one reads and everyone ignores, but through architecture, through a fundamental redesign of how data is stored, accessed, and controlled. The solution was simple in concept. What if data lived in a personal data locker instead of on corporate servers? What if individuals owned their data the same way they own their house or their car? What if access to that data required explicit, revocable permission? This was not a new idea. Privacy advocates had been arguing for data ownership for years, but most proposals relied on government enforcement or corporate compliance. They assumed that existing power structures could be reformed through better rules. Enkai took a different approach. It assumed that centralized platforms would never voluntarily give up control, that the only way to return power to individuals was to build an alternative infrastructure, one that made surveillance impossible, not because it was illegal, but because it was technically infeasible. The personal data locker was the foundation of this infrastructure, a secure, encrypted storage system controlled entirely by the individual, not hosted on Google's servers or Amazon's cloud, hosted on a distributed network where data was fragmented, encrypted, and inaccessible to anyone except the person who owned it. When Sarah discovered Enkai, she was skeptical. She had heard promises about privacy before. 5PN encrypted messaging apps, browser extensions that blocked trackers. But all of these were band-aids. They protected against specific threats without addressing the fundamental problem. The data was still being generated, stored, and controlled by someone else. The personal data locker was different. It was not a tool for hiding from surveillance. It was a tool for opting out of the surveillance economy entirely. She created her locker. She began migrating her data, her photos, her documents, her health records, her purchase history. Slowly, methodically, she pulled her digital life out of corporate servers and into infrastructure she controlled. And then something unexpected happened. She started getting offers. The first came from a data analytics company. They wanted access to her purchase history to improve their recommendation algorithms. They offered $50 per month for read-only access. She declined. The offer increased to $100. She still declined, not because the money was insufficient, but because she was beginning to understand something powerful. Her data had value, and for the first time in her life, she controlled that value. The second offer came from a health research organization. They were studying sleep patterns and exercise habits. They offered $200 per month for anonymized access to her fitness data. This time she accepted, not because she needed the money, but because she believed in the research. And because the terms were clear: anonymized data, limited access, revocable at any time. For the first time, Sarah was not the product. She was the customer. She was the owner. She was the one deciding what data to share, with whom, and on what terms. This was the human firewall. Not a technology that blocked access, but a technology that required permission. A fundamental shift from opt-out to opt-in. From surveillance by default to privacy by design. And as more people built their own firewalls, the balance of power began to shift. Companies that had built their entire business model on free access to user data suddenly found themselves negotiating, paying for access, competing for permission. The internet had been built on a model of infinite free data. Enkai was building a model where data had a price, and the price was set by the person who generated it. The signal was no longer weak. The alternative was operational. The gathering had begun. Chapter 2. Japan's Whisper. The technology that would become the foundation of Enkai did not emerge from Silicon Valley. It emerged from Tokyo, from a company called Jasmy, from a group of former Sony executives who understood something fundamental about the future of infrastructure. Jasmy was founded in 2016 by Kunitake Ando and Kazumasa Sato, both veterans of Sony's engineering and business divisions. Ando had served as president and COO of Sony Corporation. Sato had led multiple technology initiatives within the company. They had spent decades building consumer electronics, managing global supply chains, and navigating the complex relationship between hardware, software, and user experience. They had also watched the internet transform from a decentralized network into a centralized surveillance apparatus. And they believed this was not inevitable, that it was a design choice, that infrastructure could be built differently. Their insight was simple. The problem with the internet was not surveillance itself, but the architecture that made surveillance profitable. As long as data lived on corporate servers, companies had an economic incentive to harvest, analyze, and monetize it. The solution was not better privacy policies, it was infrastructure that made data harvesting impossible. The Personal Data Locker, PDL, was their answer. A secure, encrypted storage system that lived on the user's device, not on corporate servers. Data was generated locally, stored locally, and controlled locally. Access required explicit cryptographic permission, not a checkbox on a privacy policy, but a digital signature that could be verified and revoked. This was not a consumer product, it was infrastructure. The same way electrical grids, water systems, and telecommunications networks are infrastructure. Invisible, essential, foundational. But infrastructure is only valuable if people use it. And in 2016, most people did not care about data sovereignty. They cared about convenience, about free services, about apps that worked seamlessly across devices. The idea of managing your own data seemed cumbersome, technical, and unnecessary. Jasmy understood this. They were not building a product for privacy advocates or cryptography enthusiasts. They were building infrastructure that would become necessary as the costs of centralized surveillance became unbearable. They were early, but they were patient. Their first deployment was in Japan's automotive sector. Cars were becoming connected devices. They generated data about location, driving patterns, maintenance needs, and user behavior. Automakers wanted this data for product development, but consumers were increasingly wary of being tracked. The Personal Data Locker offered a solution. Drivers could own their data while selectively sharing it with manufacturers, insurers, or researchers on terms they controlled. Toyota and Honda adopted the technology, not because they were privacy advocates, but because they saw the business model shifting. Consumers were beginning to demand control. Regulations were beginning to require it. The companies that adapted early would have an advantage. The second deployment was in IoT and smart home systems. Devices like thermostats, security cameras, and voice assistants generated continuous streams of data about user behavior. This data was valuable for product improvement, but it was also invasive. The PDL allowed users to control what data was shared, when, and with whom. By 2020, Jasmy had partnerships with Panasonic, Toyota, Lexus, KDDI, and dozens of other Japanese corporations. The Personal Data Locker was no longer a concept, it was infrastructure, deployed at scale, operational. But the real breakthrough came in 2023 when Jasmy received ISO 27001 and ISMS certification. These were enterprise-grade security standards that most blockchain projects could never obtain. They required rigorous audits, documented processes, and demonstrated operational security. They were the difference between experimental technology and infrastructure that governments and corporations could trust. And then Jasmy announced something unexpected. They were building a Layer 2 blockchain. Most people misunderstood this. They thought Jasmy was pivoting to cryptocurrency, that they were chasing the speculative hype that had consumed so much of the blockchain industry. But that was not what was happening. Jasmy was not building a currency. They were building infrastructure for verifiable data transactions. The Layer 2 solution, called Junction, was designed to solve a specific problem. How do you create tamper-proof records of data transactions without the cost and complexity of a mainnet blockchain? Most blockchain projects operate on Layer 1, the base blockchain where every transaction is recorded, verified, and stored across thousands of nodes. This is secure, but it's also slow and expensive. Processing a transaction on Ethereum can cost dollars. Processing thousands of transactions per second is economically infeasible. Layer 2 solutions solve this by batching transactions off-chain and then settling them on-chain in aggregated form. The result is speed and cost efficiency without sacrificing security. Junction was not a speculative cryptocurrency. It was infrastructure for data sovereignty. When a user accessed their personal data locker, when a company requested permission, when data was shared or revoked, these actions were recorded on Junction. The records were cryptographic, immutable, auditable. This was the missing piece. Personal data lockers gave individuals control over their data. Junction gave them proof that they had granted access, proof that they had revoked it, proof that their data had not been tampered with. And this proof was not just for individuals, it was for regulators, for auditors, for courts. When a company claimed they had permission to use someone's data, that permission could be verified on-chain. When an individual claimed their data had been misused, the blockchain provided evidence. This was compliance as infrastructure, not as paperwork, but as code. By 2024, Jasmy and Junction were operational at scale. The personal data locker had been deployed across automotive, IoT, healthcare, and finance sectors in Japan. Junction was processing millions of data transactions per month. The infrastructure was proven. The technology was mature, but most of the world did not know this. Because Jasmy was not a marketing company. They were an infrastructure company. They built systems. They partnered with enterprises. They obtained certifications. They did not chase hype. And this was why Enkai mattered. Enkai was not the technology. Enkai was the application. The user-facing layer that made data sovereignty accessible to individuals. The bridge between infrastructure and adoption. Jasmy built the rails. Enkai built the train. Chapter 3, The Distributed Backbone. The year was 2024, and Michael Torres was sitting on $8,000 worth of unused compute power. He did not think of it that way. He thought of it as his gaming PC. A high-end rig with an NVIDIA RTX 4090 GPU, 64 gigabytes of RAM, and a custom water cooling system. He had built it to run AAA games at maximum settings, to render 3D models for his side projects, to mine cryptocurrency when prices were high. But most of the time, the machine sat idle. He worked during the day, he gamed a few hours in the evening. The rest of the time, 16, 18, 20 hours per day, the GPU was doing nothing. Generating heat, consuming electricity, depreciating in value. This was true for millions of people. Gamers, designers, engineers, researchers. Anyone with a high-performance computer had compute power that sat unused most of the time. The global supply of idle GPUs was enormous, but it was fragmented, distributed, inaccessible. Until Junction. Junction was not just a blockchain for data transactions. It was a distributed compute network, a marketplace where people with unused compute power could rent it to people who needed it. Not through a centralized platform like AWS or Google Cloud, but through a peer-to-peer network where transactions were verified cryptographically. Michael discovered Junction through a Reddit post. Someone had shared a screenshot showing $1,200 in monthly earnings from renting out their GPU. Michael was skeptical. He had tried cryptocurrency mining before. The returns were marginal. The electricity costs were high. The volatility was stressful. But Junction was different. It was not mining. It was compute rental. Companies and individuals needed GPU power for machine learning, video rendering, data analysis, and AI training. They were willing to pay for access. And because the network was decentralized, the rates were competitive with cloud providers, but the margins were better for node operators. Michael installed the Junction node software. He configured his GPU to be available when he was not using it. He set his rates based on the network average, and then he waited. The first request came within an hour. A machine learning researcher needed GPU power to train a natural language processing model. The job would take 6 hours. The payment was $18. Michael accepted. His GPU spun up. The job ran in the background while he worked. 6 hours later, the job completed. The payment arrived in his Junction wallet. $18. Verified on-chain. No intermediary. No platform fee. Over the next month, Michael earned $1,100. His electricity costs were about $40. His net income was $1,060 for doing nothing, for letting his computer do what it was already capable of doing just for someone else. But the real value was not the income. It was the architecture. Michael was not working for a company. He was not an employee or a contractor. He was a node in a distributed network. He contributed compute power. He was compensated fairly. The network grew stronger because he participated. This was the distributed backbone. Not a centralized cloud controlled by Amazon or Google. Not a blockchain network that required specialized hardware. Just ordinary people with ordinary computers contributing to a network that made compute power accessible, affordable, and decentralized. And this was the infrastructure that Enkai would run on. When Sarah Chen processed her travel documentation, when David automated his tax deductions, when Lisa generated her compliance reports, the compute power came from people like Michael, not from corporate data centers. From a mesh of distributed nodes, the backbone was operational, the infrastructure was scaling, and the people who contributed to it were earning income while they slept. Chapter 4: The Identity Layer. Identity is the foundation of the digital world. Without identity, there is no trust. No transactions, no relationships, no coordination, but identity in the current system is broken, fragmented, controlled by platforms that can revoke it at will. Your email address is your identity on Google. Your username is your identity on Twitter. Your phone number is your identity on WhatsApp. Each platform owns a piece of your identity. And if they decide to suspend your account, ban your profile, or delete your data, you lose that piece of yourself. This is not identity. This is permission. You do not own your identity. You rent it from platforms that can take it away. Enkai required a different model. A model where identity was sovereign. Par tab. Verifiable, where you owned your identity the same way you owned your name, where access to platforms required your permission, not the other way around. This was not a new idea. Decentralized identity protocols had existed for years, but most were theoretical, academic, not deployed at scale, not integrated with real-world systems. Enkai used a combination of existing identity standards, W3C, decentralized identifiers, verifiable credentials, and biometric authentication. The result was an identity system that was cryptographically secure, privacy-preserving, and interoperable. When you created an Enkai account, you did not provide an email address or phone number. You generated a cryptographic key pair. Your public key was your identity. Your private key was your proof of ownership. No platform could revoke it. No company could delete it. No government could confiscate it. But identity is not just about authentication. It is about reputation, about trust, about the social fabric that makes coordination possible. In the old model, reputation lived on platforms. Your Amazon reviews, your Uber rating, your LinkedIn endorsements. If you left the platform, you lost your reputation. You started from zero. In Enkai, reputation was portable. When you invited someone to the network, you vouched for them. When they behaved well, your reputation improved. When they behaved poorly, your reputation suffered. This created a web of trust, a social graph where relationships were verifiable and reputation was earned. This was not surveillance. Your identity was pseudonymous, your data was private, but your behavior was accountable, because accountability is what makes trust possible. And this was the identity layer. Not a username and password, not an email address controlled by Google, but a sovereign cryptographic identity that you owned, controlled, and carried with you across the digital world. Chapter 5: The Freedom Engine. David Park was a consultant. He traveled constantly. Client meetings in Austin, conferences in Denver, site visits in Seattle. His calendar was a patchwork of flights, hotels, and rental cars. And every year, tax season was a nightmare. He knew he could deduct business travel expenses, flights, hotels, meals, mileage. But documenting everything was overwhelming. He saved receipts, he tracked mileage manually, He tried to remember which trips were business and which were personal. And inevitably, he missed deductions. Thousands of dollars left on the table because the documentation was incomplete. His accountant told him the same thing every year. You need contemporaneous records. The IRS requires documentation at the time of the expense. Reconstructing it later is not compliant. David knew this, but he did not have time to log every expense, every trip, every meeting. He was busy running his business. The administrative burden was crushing. And then he discovered Enkai. Enkai's Freedom Engine was designed to solve exactly this problem. It automated compliance, it tracked business travel in real time, it generated contemporaneous documentation that met IRS standards. And it did all of this invisibly in the background without requiring effort from the user. The system worked like this. David's phone, connected to his personal data locker, tracked his location. When he boarded a flight, the system logged it. When he checked into a hotel, the system recorded it. When he drove to a client meeting, the system calculated mileage. But the system did not just track data, it interpreted it, it understood context, it used machine learning to distinguish business travel from personal travel, it cross-referenced calendar entries, email communications, and transaction records to determine the purpose of each trip. And then it generated documentation, automatically, contemporaneously, compliantly. David did not have to do anything. He just lived his life. The system observed his activities and categorized them for tax purposes. A flight to Austin with a client meeting the next day was clearly business travel. A dinner with a prospective client was a business meal. Mileage driven between meetings was deductible. The system generated a contemporaneous log of business activities. Every trip, every expense, every meeting. The documentation was timestamped, encrypted, and stored in David's PDL. When tax season arrived, his accountant received a verified report with all the necessary information. No guessing, no reconstructing, no lost receipts. David claimed $34,000 in deductions for 2025. All of it documented, all of it compliant, all of it generated automatically. The first year, he saved $10,200 in taxes. The Enkai subscription cost $600 per year. The return on investment was immediate and undeniable. But the value was not just economic, it was psychological. David no longer felt anxious about audits. He no longer spent weekends trying to reconstruct his travel history. He no longer worried that he was overpaying taxes because his documentation was incomplete. The system had turned compliance from a burden into a background process. It ran invisibly. It did not require effort. It just worked. And this was the point. Enkai was not about technology for its own sake. It was about removing friction, about making the right thing easy and the wrong thing hard. About architecting systems so that compliance was the default, not the exception. But there was a deeper principle at work. The Freedom Engine was not just about tax deductions, it was about ownership, about control, about the fundamental question of who owns your data and what they can do with it. In the old model, David's travel data lived on Google servers, his transaction data lived on his bank servers, his communication data lived on his email provider servers. All of this data was used to build a profile of his life, a profile that was sold to advertisers, analyzed by algorithms, and exploited for profit. David did not consent to this in any meaningful way. He had clicked "I agree" on privacy policies he never read. But consent is meaningless when the alternative is opting out of modern life. The personal data locker inverted this model. David's data lived on infrastructure he controlled. It was encrypted, it was private, it was his. If a company wanted access, to offer him a service, to improve a product, to conduct research, they had to ask. And he could say no, or he could say yes, but only on terms he found acceptable. This was not theoretical privacy, this was operational privacy, not because laws required it, not because corporations promised it, but because the architecture made it impossible for anyone else to access the data without permission. And this was the engine, the force that would drive the gathering world. Not ideology, not activism, not political movements, just individuals opting into infrastructure that aligned with their interests. Infrastructure that made their lives better, easier, and more profitable. When David told his friends about Enkai, they did not ask about blockchain or distributed compute or cryptographic protocols. They asked, "How much money did you save?" And when he told them, they signed up. This was the viral loop. Not marketing, not advertising, just results. People who used Enkai saved money. Their friends noticed, their accountants noticed, their colleagues noticed, and they signed up. By 2025, Enkai had 50,000 users. By 2026, it had 200,000. The growth was organic, steady, sustainable, not fueled by venture capital or paid acquisition, fueled by word of mouth and demonstrated value. But the most important metric was not user growth. It was data sovereignty. 200,000 people now owned their travel data, their transaction data, their business documentation. This data lived in personal data lockers, encrypted and private. It was not being harvested by Google. It was not being analyzed by Meta. It was not being sold to data brokers. 200,000 people had opted out of surveillance capitalism, not by deleting their accounts or moving to the woods, just by using an alternative. An alternative that worked, that made their lives better, that aligned with their interests. This was the Freedom Engine. Not a revolutionary manifesto, not a political movement, just infrastructure that made ownership easy, privacy default and compliance automatic. And as more people adopted it, the balance of power shifted. Companies that had built their business models on free access to user data found themselves competing for permission, negotiating terms, paying for access. The internet had been built on a model where data was free and users were the product. Enkai was building a model where data had value and users set the price. The engine was running, the gathering was accelerating, and the infrastructure that made it possible was operational, proven, and scaling. Freedom was no longer an aspiration, it was architecture. Chapter 6: The Mesh Economy. The traditional economy runs on hierarchies: employers and employees, corporations and contractors, platforms and users. Value flows upward, control flows downward. The people at the bottom generate the value. The people at the top extract it. This is not a moral judgment. It is an observation about structure, about architecture, about how economic systems are designed. But there is another model, not a hierarchy, but a mesh, not a pyramid, but a network. In a mesh economy, value flows in multiple directions. Participants are not employees or users. They are nodes. They contribute to the network. They benefit from the network. And the network benefits from their participation. Enkai was designed as a mesh economy, not because of ideology, but because of architecture. The system only worked if participants were aligned, if they contributed data, compute, verification, and trust, if they invited others, vouched for quality, and maintained standards. The economic model reflected this. When you invited someone to Enkai, you earned 25% of the value they generated. Forever. When they invited someone, you earned 10% of that person's value. 2 generations. Permanent commission. This was not multi-level marketing. MLM structures typically have unlimited generations, creating exponential growth that becomes mathematically unsustainable. Enkai capped at 2 generations. The model was stable, bounded, sustainable. But more importantly, it was aligned. When you invited someone to Enkai, you had skin in the game. If they generated value, you benefited. If they were a bad actor, it reflected on you. The network incentivized quality over quantity. This was how trust scales in a decentralized system. Not through corporate oversight or algorithmic moderation, but through reputation and economic alignment. You vouched for the people you invited because their behavior affected your reputation and your income. Lisa Chen was an early Enkai member. She joined in early 2025, attracted by the tax deduction automation. She used the platform for 6 months, documented $45,000 in business travel expenses, and saved $13,500 in taxes. The platform paid for itself 20 times over. But then she started thinking about the invitation structure. She was a business consultant with a network of entrepreneurs, freelancers, and remote workers. All of them traveled, all of them had business expenses, most of them were not documenting properly, they were leaving money on the table. She sent invitations to 10 people in her network. All of them signed up, 9 of them became active users. Over the next year, those 9 people collectively generated $180,000 in tax deductions. Lisa earned 25% commission on the platform fees they paid, about $4,500. But the real value came from the second generation. 3 of the people she invited started inviting their own networks. Those invitees generated another $300,000 in deductions. Lisa earned 10% on that activity, another $3,000. In total, Lisa earned $7,500 per year from invitations. She had not sold anything, she had not recruited anyone, she had simply shared a tool that solved a real problem for people she knew. And because the value was genuine, they stayed. They used the platform. They invited others. This was The mesh economy in practice. Lisa was not Lisa's boss. Enkai was not Lisa's employer. Lisa was a node in a network. She contributed by inviting qualified members. She benefited through commissions. The network benefited through growth and quality. But the mesh extended beyond just human participants. Remember Michael Torres, the node operator from Chapter 3? He was earning $1,000 per month by contributing GPU compute power to Junction. That compute power was being used by Enkai members to process their travel documentation, analyze their expense patterns, and generate tax reports. Michael was part of the mesh. He contributed compute. Enkai members used that compute. Michael earned income, the members got their reports, the network became stronger because both sides benefited. And then there were the business partnerships, resorts, airlines, rental car companies. These were not advertisers paying for access to Enkai members. They were partners contributing to the ecosystem. When a resort partnered with Enkai, they offered verified accommodations to members. When a member booked through the platform, the resort received a customer, the member received compliant documentation, and the person who invited that member earned a commission. Everyone contributed. Everyone benefited. The value flowed in multiple directions. This was fundamentally different from platform economies like Uber or Airbnb. In those systems, the platform sat in the middle, extracting 20 to 30% of every transaction. The value flowed to the center. The participants, drivers, hosts, riders, guests, were interchangeable units. The platform owned the relationship. In a mesh economy, there was no center. Enkai did not own the relationship between members and resorts. It facilitated the connection. Enkai did not own the compute infrastructure. It coordinated access to a distributed network of node operators. Enkai did not own the data. It provided tools for members to own and control their data. The platform was thin. The network was thick. The value accumulated to participants, not to the platform. This had profound implications for long-term sustainability. Platform companies grew by extracting more value from participants. They raised fees. They degraded service. They prioritized shareholders over users. This was not greed. It was structure. When the platform is the center, it must grow by extracting from the edges. But in a mesh economy, growth came from network effects. The more participants, the more valuable the network. The more node operators, the cheaper the compute. The more business partnerships, the better the options. The more invitations, the stronger the trust. The platform grew by making the network more valuable, and the network was owned by the participants. By 2027, Enkai had grown to 2 million members. The mesh economy was operational at scale. Node operators were earning passive income, members were saving money on taxes, business partners were acquiring customers, inviters were building generational wealth. And all of this was happening without venture capital, without paid advertising, without a sales team, just through aligned incentives, through a network where everyone contributed and everyone benefited. This was the mesh economy. Not a theory, not a manifesto, just infrastructure that aligned economic interests with network growth. And as the mesh grew, it became more resilient, more distributed, more valuable, because in a mesh, there is no single point of failure, no CEO who can be replaced, no board that can change direction, no platform that can be shut down. The mesh was the network, and the network was the participants, and the participants owned the value they created. This was the economy of the gathering world. Not extraction, alignment, not hierarchy, mesh, not platforms, networks. And it was operational. Proven, scaling. Chapter 7, The Infrastructure Imperative. The year was 2016, and Kunitake Ando had a problem. He had just left Sony Corporation after serving as president and COO. He had spent decades building consumer electronics, managing global supply chains, and navigating the complex relationship between hardware, software, and user experience. But he had also watched the internet transform from a decentralized network into a centralized surveillance apparatus. And he believed this was not inevitable, that it was a design choice, that infrastructure could be built differently. The problem was not technology. The protocols existed. Cryptography was mature. Distributed systems were proven. The problem was deployment. How do you build infrastructure that governments trust, that enterprises adopt, that scales to millions of users? Most blockchain projects ignored this question. They prioritized decentralization over reliability. They moved fast and broke things. They chased hype cycles instead of operational deployment. They built experimental technology that worked in theory but failed in practice. Ando took a different approach. He founded Jasmy with Kazumasa Sato, another Sony veteran. Together, they decided to build infrastructure the way Sony had built consumer electronics, with rigorous engineering, enterprise-grade security, and operational reliability. They did not launch a token. They did not run an ICO. They did not chase venture capital. They partnered with corporations. They obtained certifications. They deployed at scale. The personal data locker was not a consumer product. It was infrastructure. The same way electrical grids, water systems, and telecommunications networks are infrastructure. Invisible, essential, foundational. Their first deployment was in Japan's automotive sector. Cars were becoming connected devices. They generated data about location, driving patterns, maintenance needs, and user behavior. Automakers wanted this data for product development, but consumers were increasingly wary of being tracked. The personal data locker offered a solution. Drivers could own their data while selectively sharing it with manufacturers, insurers, or researchers on terms they controlled. Toyota and Honda adopted the technology, not because they were privacy advocates, but because they saw the business model shifting. Consumers were beginning to demand control, regulations were beginning to require it. The companies that adapted early would have an advantage. By 2020, Jasmy had partnerships with Panasonic, Toyota, Lexus, KDDI, and dozens of other Japanese corporations. The personal data locker was no longer a concept, it was infrastructure, deployed at scale, operational. But the real breakthrough came in 2023, when Jasmy received ISO 27001 and ISMS certification. These were enterprise-grade security standards that most blockchain projects could never obtain. They required rigorous audits, documented processes, and demonstrated operational security. And then came the partnerships that proved Jasmy was not just another blockchain project. In 2024, Jasmy partnered with KDDI, Japan's second-largest telecommunications company, to integrate personal data lockers into mobile devices. This was not a pilot program, this was operational infrastructure serving millions of users. The same year, Jasmy partnered with Japan's My Number Card system, a national digital identity initiative that served over 100 million Japanese citizens. The integration allowed individuals to store their government-issued credentials in personal data lockers, not on government servers, not in a centralized database, in encrypted storage controlled by the individual. This was the scale at which Jasmy operated. Not thousands of users, not early adopters, millions of citizens using infrastructure that governments trusted. But the partnerships extended beyond identity and automotive. Jasmy integrated with smart home systems through Panasonic and Tesla. Personal data lockers managed device permissions, energy usage data, and home automation protocols. The infrastructure was invisible but essential. In healthcare, Jasmy partnered with the University of Tokyo and Digital Hollywood University to develop federated AI systems. These systems could analyze patient data without centralizing it. Hospitals could collaborate on research without exposing sensitive information. Machine learning models could be trained on distributed datasets while maintaining patient privacy. This was the promise of decentralized AI. The ability to learn from data without owning it. The ability to collaborate without centralizing. The ability to build intelligence while preserving sovereignty. Jasmy's infrastructure made this possible, not through white papers or conference presentations, through operational deployments at academic institutions and healthcare systems. But Jasmy was only half of the story. The other half was Janction. Hiroshi Harada was CFO of Jasmy and CEO of Janction. This was not a coincidence. The two companies were intentionally integrated. Jasmy provided the personal data locker for secure storage. Janction provided the Layer 2 blockchain for verifiable transactions and the distributed GPU network for compute power. Together, they solved the fundamental problem of decentralized infrastructure. How do you achieve security, trust, compliance, and authenticity without centralized control? Janction's technical specifications demonstrated the answer. Layer 2 architecture, built on top of existing blockchain infrastructure to achieve fast transaction speeds and low costs, while maintaining security through cryptographic verification. Zero-knowledge proofs allowed verification of data transactions without exposing the data itself. You could prove that a transaction occurred, under what terms, and between which parties, without revealing the contents. Decentralized identity, Zuma SGP32 compliance for remote eSIM provisioning, EUIC for embedded SIM management, multi-profile cellular management through Soracom. These were not buzzwords. These were technical standards that enabled sovereign identity across devices and networks. Automotive Edge Computing. Partnership with AECC, Automotive Edge Computing Consortium, to process data at the edge rather than in centralized cloud servers. Reduced latency, enhanced privacy, enabled real-time applications like autonomous driving and predictive maintenance. Smart grid integration, Panasonic-Tesla partnership for vehicle-to-grid energy trading. Patent-led microgrid stabilization. Households with solar panels and battery storage could sell excess electricity to neighbors. Electric vehicles could act as mobile battery packs, stabilizing the grid during peak demand. This was not speculative technology, this was operational infrastructure deployed at scale. By 2026, Jiangshan's targets were clear. Tens of millions of personal data lockers deployed globally. Integration with national identity systems in multiple countries. Partnerships with automotive manufacturers across Asia, Europe, and North America. These were not startup ambitions, these were infrastructure goals. The kind of goals that require enterprise-grade security, government approvals, and operational reliability. And this was the critical insight. Decentralized infrastructure only works if it is as reliable as centralized infrastructure. Users will not adopt systems that are slower, more expensive, or less reliable than the platforms they already use. Developers will not build on infrastructure that might disappear. Governments will not integrate with systems that cannot prove compliance. Jasmy and Jiangshan understood this. They built infrastructure that met enterprise standards, they obtained the certifications, they formed the partnerships, they proved reliability through operational deployment. This is why Enkai was possible. Not because Mark Reddick invented new technology, but because he recognized how existing technologies, built intentionally by people who understood infrastructure, could be assembled into something greater. Jasmy provided the personal data locker, the secure storage, the data sovereignty, the cryptographic verification. Jiangshan provided the Layer 2 blockchain, the distributed compute network, the verifiable transactions, the zero-knowledge proofs. Together, they formed the mycelium, the invisible network beneath the surface that made everything else possible. Enkai was the application layer, the interface, the platform that made this infrastructure accessible to millions of people who did not know and did not need to know that they were using personal data lockers, distributed GPU networks, or zero-knowledge proofs. They just needed it to work, and it worked because the infrastructure was operational, proven, reliable, enterprise-grade. This is the infrastructure imperative. You cannot build the future on experimental technology. You cannot achieve adoption without reliability. You cannot scale without security. You cannot maintain trust without compliance. The decentralized web will not be built by startups that prioritize growth over security. It will not be built by projects that move fast and break things. It will not be built by idealists who ignore the operational realities of enterprise adoption. It will be built by people who understand infrastructure, who have spent decades mastering the old system, who know what it takes to achieve scale, reliability, and trust. Jasmy and Jiangshan are that infrastructure. Not perfect, not complete, but operational, proven, growing, and Mark Reddick saw the mycelium, the connections, the way these systems fit together to form something greater than their parts. He architected Enkai by recognizing that the infrastructure already existed, that the protocols were proven, that the partnerships were operational, that the missing piece was not technology but application, not invention but assembly, not disruption but integration. The infrastructure imperative is simple. Build on what works, recognize what exists, assemble rather than invent, integrate rather than compete. Enkai is not a competitor to Jasmy or Jiangshan. It is a platform built on top of their infrastructure. It is the application layer that makes their technology useful to people who do not care about cryptography, distributed systems, or blockchain protocols. And that is how the future is built. Not through disruption, through integration, through recognizing the mycelium and building the fruiting bodies that make the invisible infrastructure visible, accessible, and valuable. The infrastructure is operational, the protocols are proven, the partnerships are established. Now, the world can gather. Epilogue, the signal that never died. Sarah Chen sat on her porch in 2030, watching her daughter play in the yard. It had been 7 years since she received that email from her insurance company. 7 years since she discovered Enkai. 7 years since she took control of her data. The world had changed. Not dramatically, not overnight, but steadily, quietly, inevitably. By 2030, over 50 million people used Enkai or similar platforms built on the same infrastructure. Personal data lockers were standard, distributed compute was common, sovereign identity was expected. The surveillance economy had not disappeared, but it had competition. Real competition, operational alternatives. Sarah's daughter would grow up in a world where data sovereignty was default, where compute power was distributed, where identity was portable, where reputation was verifiable, where coordination did not require centralized control. She would not remember the surveillance capitalism of the 2010s and 2020s. She would not remember when companies could take your data without asking. She would not remember when alternatives did not exist. She would just remember the world as it was. A world where infrastructure aligned with human interests, where protocols enabled coordination without coercion, where the gathering had become so complete that it was no longer visible. The signal had never died. It had just become the background hum, the operating system, the substrate of digital civilization. And Mark Reddick, sitting at his desk in 2030, reflected on the journey. He had not invented the technology, he had not built the infrastructure, he had simply seen the mycelium, the connections, the way independent systems could be assembled into something greater. He had architected platforms, civilization layers, operating systems for human coordination in a decentralized world, and now those systems were running, operational, scaled, invisible. The gathering was complete. The infrastructure was operational. The future had arrived, and it had arrived quietly, without fanfare, without revolution, just through infrastructure that worked. The signal that never died was now the hum of civilization, the substrate on which everything else was built, the mycelium that connected everything beneath the surface. And the world finally was gathering, not around platforms, not around corporations, not around governments, but around infrastructure, protocols, standards, systems that aligned with human interests instead of extracting from them. This was not the end, it was the beginning. The foundation